Hello and welcome everyone to Know Your Scientist series presented by Kshama Ahmedabad Academy of Sciences. Today we have our first guest, Professor Prasanna sir, who is a retired scientist. We welcome you to our first episode, sir.
Thank you so much.
This is how we start these interviews, as in I was going to give your introduction, but then I was given your CV. And I opened it, it was 30 pages long. And I was just flabbergasted about, oh my god, like the experiences and the, the exposures that you've gone through. It's just amazing.
After 60 years of
exactly 60 years of experience in Professor Prasanna is basically a theoretical physicist, if it is correctly quoted. What would you rather quote yourself?
Yes, a mathematical physicist.
A mathematical physicist, more specialized in general theory of relativity, right? Okay, sir. So let's start with your early life. My first question goes like, how would you describe 12-year-old self today?
Oh, 12. I had already finished my matriculation and I was in the pre-university. In those days there used to be 1 year before the degree college.
Okay. So
for pre-university.
It is like our 10th standard, can we?
No,
before
after 12th.
At 12-year-old?
No, I have finished my 12th at 11 years.
12th standard, that what we usually...
let me put it this way. 1954 to 57. 57, I'm sorry. 57, I finished my matriculation. The matriculation is equivalent to 12th standard of today. Since I was very much interested in science, my interest in science started almost from my 10th standard, equivalent of that. And what is most interesting is, when I was in matriculation, that is a 12th standard equivalent, in Bangalore, is the city of Sir C.V. Raman.
Yeah.
His institute is there.
Yes.
And we used to live in Malleshwaram. And his institute was about just 2 kilometers from our house.
Okay.
So I used to go around normally and the Institute of Science also was very close by to our house.
Yeah.
So we used to take walks in those places.
Okay.
And Sir C.V. Raman had started a program. Every Gandhi Jayanti, October 2nd, he used to give a public lecture, popular lecture. And one had to register for that because auditorium was, capacity was about just 200.
So it used to get full at those times to house full?
Yes, it used to get house because Institute of Science was nearby and colleges, staff, faculty and maybe mostly from the Institute of Science, people used to come. So I had registered myself. So every October 2nd I used to go for his lecture. But the most interesting thing was, after that next year, just before the lecture day, I was planning to go a little early if I could get a chance to talk to Professor Raman. And I was barely 16. And so it just happened that as I went in, because it is a house is behind and it has a big garden, rose garden.
Okay.
So I entered. To my luck, Professor Raman was coming for his regular walk into the garden. So I just said and greeted with the usual namaskar. He said, yes. And then I said, I wanted to talk to you. Come. He put his hand on my shoulder here and then we walked together.
Great.
And it was so exhilarating to me. I felt, something, a day is made. And then he kept on talking about what is science, how science should be made. And he imbibed in me that spirit of science. And then, of course, that was just about 10 minutes. And then we went to the lecture hall where he had his lecture. And I still remember that was the lecture on color vision. It was so beautiful. Even today, I can see that blackboard he was filling with words and figures. It was very, very beautiful. It was very impressive. And my interest in physics, of course, grew tenfold. I decided that if I do anything in my life, it's going to be physics. So after my graduation, or after that is the time when people are selecting for engineering or medicine. I declined to
Go with
apply
that.
to either of that. And most of the family was a little annoyed with me.
Okay.
And so, but I didn't bother too much. Luckily, my parents supported me fully on that. So I did my BSc, Bachelor of Science, and then went for Mathematics Masters. So that I finished my Mathematics Masters in 1964. So then, I thought it was when I had gone for a holiday in summer vacation to my aunt's house in Bhadravati. And one day in a daily newspaper, Deccan Herald, I read a news that the Institute of Mathematical Sciences in Madras was going to conduct their yearly seminar in Bangalore in sometime in September, it had said. And it had given the name of the director, Alladi Ramakrishnan. I just took a chance. I just took a postcard and wrote, I have finished my master's in mathematics with distinction. I would like to do research and I would like an opportunity in your institution. And I was not very sure that any response would come. But to my surprise and to my luck, just after a week, I received a response from his personal assistant saying that we will be in Bangalore for this seminar. So you can come and meet me there in Bangalore in Hotel Woodlands. So I returned back to Bangalore immediately, and then I went to see him. So he met and spoke to me for a while, and he smiled and said, okay, I'll give you a scholarship of rupees 150 per month. You come, do anything you want. I was really flabbergasted, but it was very good. So 1965 it was, and then I went there to math science, and I started doing studying, because theory of relativity is something which I had read about as a young student in school. One is a book by Bertrand Russell called ABC of Relativity.
It consists of basics about
Yeah, it is just very lucidly written. And then another one, Universe and Dr. Einstein, another book. These two had really impressed me very much. So I started with special relativity, slowly learning myself. Because I always believed that learning oneself is far better than getting taught by somebody. So because when you are learning for yourself, you will be very careful and you will try to work out the details and try to see that you have understood the thing. So I did that, and I was religiously working on the subject in math science as a research student. And one great thing was Professor Alladi Ramakrishnan used to invite almost all the dignitaries in science from all over the world to his institute to spend some time and give lectures. So I had the privilege of listening to a galaxy of physicists. Really, it was a great institute. And then I had the privilege of writing the lecture notes of 2 or 3 of them, of the lectures that they gave.
At the age of 20, you had this privilege of doing whatever you want.
Yes.
You met C.V. Raman. You already had this letter replied from the scientist. And now...
And I started doing that. And Professor P.C. Vaidya from Ahmedabad, you might have heard of him. He is the relativity person.
Okay.
There is a solution called Vaidya solution.
I was not aware of this.
No, it's a very famous solution for a radiating mass particle. And Alladi Ramakrishnan had invited him. He came for 2 weeks and he gave a course of lectures on general relativity and cosmology. And I meticulously took down notes and made a full lecture notes of that, which was brought out as a report by Math Science. It's called Math Science Report. And then Professor Vaidya, when he saw my lecture notes, he was quite impressed. I said, I want to do my Ph.D. in this subject. And in Institute of Mathematical Sciences, that is Math Science, there was nobody with the expertise of relativity. So Professor Vaidya then suggested, you come to Gujarat to work with me, or he gave the chance Professor Vivian Narlikar, that is Jayant Narlikar's father, who was the first relativist in India. I'll tell you about him, which is very interesting. And he was taking over as the Lokmanya Tilak professor at Pune University.
Okay.
He said, you can go to him also. So, and my father particularly said he had heard, unfortunately in those days, Gujarat was not known for education, only for business.
Yeah.
And Pune was, of course, known for culture and all. So my father said, why don't you go to Pune? So I wrote a letter to Professor Narlikar showing my interest and my master's certificate and all. So he said, come for an interview. So I went to Pune for interview and he selected me. He said, I'll get you a scholarship from the university and you can start working with me. So I took that. So 66 October, I started in Pune. Because 65, 66 I had spent in Institute of Mathematical Sciences.
Okay.
And 66 October I came to Pune to start my Ph.D. work with Professor Narlikar. And that went on for 3 years. I finished whatever he asked me to do. I finished the thing 69 December, my thesis was complete. So it was submitted. And Professor Ramakrishnan, when I left to come to Pune from Institute, he had suggested that you can, after you finish, whenever you want to come back here, you should just write me a letter and come back. So after my PhD, I went back to Institute of Mathematical Sciences and continued my research there. I was in Institute of Mathematical Sciences as what they call postdoctoral fellow.
Yes.
They're called visiting scientist. Then in 72, in Trieste, International Center for Theoretical Physics, there was a big conference to honor Professor Dirac.
Okay.
His 70th birthday. And it was an international conference. And I wrote to Professor Salam, who is the director of the institute there, and he said that instead of just coming for the meeting, I could go there as a visiting scientist for 1 year. He offered me a postdoctoral fellowship. So I went, along with, also in 1972, we got married.
Okay.
I had met my future wife in Madras, in the Institute of Mathematical Sciences.
So,
She had joined there to do her PhD in mathematics.
okay.
And so we got married in 72, and 72 September we left for Trieste, ICTP. So I spent there 1 year, and there I met Professor Bloiler from Germany. You are a student of physics, so there is something called second quantization.
Yeah.
And that is Gupta-Bloiler formalism is there. And that Bloiler, he had come to ICTP, and I spoke to him. At that time I was working on what's called Einstein-Cartan theory. Let me give a brief introduction of what this is.
Please.
Einstein produced general relativity, where you will treat gravitation as curvature of space-time.
Right.
And it's a beautiful theory. If at all there is a perfect theory, mathematically beautiful, it is general relativity.
Yes.
And it so happens that among all the physical theories, this is the one theory which has been tested by different standards, and it has come out successful in every standard.
Yes.
There have been some alternative theories, but everywhere GR comes first.
Yes.
So, but then general relativity talks only about mass. Mass influencing the curvature.
Right.
Then, way back in 1912, even before, 1927, I think, 1927, Cartan, Henry Cartan, he had thought of bringing in spin.
Okay.
Now, spin generally people talk in terms of quantum aspects.
Yes.
But this is classical spin. Supposing a rotating body is there, it has a spin.
Yes.
And now you want to include that along with the mass to geometrize
Space and time.
space and time, then you need something else.
Yes.
And that is very interestingly, Einstein's theory of relativity is based on Riemannian geometry,
Okay.
where what we use connection. A connection is something, a mathematical entity which is needed to take a vector from one point to another point along a line.
Yes, yes.
That connection in Riemannian geometry is symmetric.
Okay.
That is, if it is represented by a 3-index symbol gamma ijk, it is in j and k, it is symmetric. Ijk is equal to ikj.
Cycles.
But then Cartan introduced asymmetric connection, because in a general manifold, unlike Riemannian manifold, the connection is
Not symmetric.
not symmetric, asymmetric.
Yeah.
There is an antisymmetric.
Okay.
So Cartan thought that antisymmetric part of the connection should be related to spin.
Okay.
So it's called Einstein-Cartan theory, extension of Cartan, Einstein's theory. And in this Dirac symposium, Professor Trautmann from Poland had given a lecture on this Einstein-Cartan theory. It impressed me very much, and I started working on that. While I was there in ICTP, that 1 year, I spent all my time working on Einstein-Cartan theory. I produced a solution for that, and that's the one. So Professor Bloiler was also interested in it. So when he saw me working on it, he said I could go to Germany to his institute, and he would recommend me for a Humboldt fellowship, von Humboldt fellowship. So I agreed, and I got a von Humboldt fellowship in 1973. 72-73 I was in Trieste, and 73 I went to Bonn and joined this institute, and then I was working on this only. That is 73, 74, 74, 75. I was there as a Humboldt scholar in this institute. Professor Ian Mitra from Delhi University was visiting Bonn, and he suggested I could go to Delhi if I like, and I could join the department there. So I was wondering, I was somehow keen on joining a research institute. And so, physical research laboratory, which I had heard of, and in fact, I had visited in the sense that, in 1969, that was the 60th year, 60th year of Professor V.V. Narlikar. And to celebrate his 60th year, Professor Vaidya had arranged a seminar, All India seminar, in Ahmedabad. Yeah. And as a student in 1969, I had come from Pune to Ahmedabad for that seminar. So I had seen PRL. It was, I had known that it is Vikram Sarabhai's institute and all that. So then I thought, Professor Vaidya was here anyway.
Right.
So I asked Professor Vaidya. He said, yes, you could come to PRL. And so Jayant Narlikar, by that time, he was already a professor, well-known professor in Tata Institute. Professor Vaidya both suggested to Professor Lal, who was the director of PRL at that time, about my name. And then, so I got a letter from Professor Pandya, who was the deputy director, that I could come as a visiting scientist. And then, because normally that is how entries are made.
Yeah.
So after a year, we will see what happens. So I returned to India. We returned to India end of 75. I joined PRL as a visiting scientist. That was for about a couple of months. And in 3 months or 4 months, I don't remember, about February 77 February, I got a permanent position in PRL.
Sir, I have been hearing this, and I feel that you've been consistently lucky with so much of magnitude. I would like to know the secret behind this luck. What would you consider it?
Maybe just my interest and my sincerity.
Great.
In fact, it's something that I have understood, that if you want to do something, and if you really try hard, you will be able to do it. And of course, success is always not guaranteed.
Yeah.
You may succeed sometime, you may not succeed sometime. But don't give up.
Right.
Because something did not happen, one should never give up. Continue. Take another line. There are different streams.
So, have you had any redirection in your life or any failures that you faced?
No, I cannot say failure, but well, maybe sometimes some disappointments. Sometimes, research is something which is not a guaranteed
Yeah,
thing.
you can't always.
So you take a problem, you start working on it, then sometimes you get the result fast,
Yeah.
sometimes you don't, then you have to maybe change the way you are
Approach,
doing
yes.
it. So that's what one has to do. And so such disappointments, like anybody will have, or maybe I also had. But I kept my aim that I have to do this, because my aim was to understand the theory of gravity through general relativity, and I apply it to astrophysics. That's how I'm a student of relativistic astrophysics.
Right.
My entire study after coming to PRL has been in the field of relativistic astrophysics. It is essentially, black holes.
Yes.
Now everybody talks about black holes.
Right.
But then how does one prove, how does one see where is a black hole, how does one realize it? Because they won't emit anything.
Yes.
But then there is a process called accretion.
Okay.
Now black hole is already a very highly compact object.
Yeah, of course. Yeah.
And therefore its potential is extremely large,
Right.
gravitational potential.
Almost infinite.
Not infinite, there is a
There
formula
is-
for it.
Okay.
But then, because this is denoted by Gm and by R,
Hmm.
that's the potential
equation.
energy.
Yes.
So when you see that, the particle comes near that, there's a strong attractive force by this.
Yes.
And so, it is so, if there is a flow of matter, it attracts it.
Yes.
That's called accretion.
Okay.
Accretion theory had just started in the 70s
Okay.
in astrophysics. So I took up that as my aim, and then even my students who took my PhD students, most of them worked on that. So we developed that, and most of my work is on accretions in astrophysics and relativistic. So the theory, main thing what you require is you have to do this hydrodynamics, because this is, you are treating a gas or a fluid in the vicinity of a black hole. So the gravitational potential is very high. And then what happens is, because the black hole is turning, supposing, or even otherwise, any coming matter will have angular momentum.
Yes.
Once it has angular momentum, it starts revolving around it.
Right.
And so there is a last or stable orbit. Above that, it will be sucked in.
Yeah. This somewhat this concept has been shown in the Interstellar
Yes, movie.
That the borderline has some name.
So yes, the photon radius is there,
Okay.
and we call it photon radius. The R equal to 3m,
Okay.
but R equal to 6m. If R is the radius of the body,
black-
is solid,
okay.
at 6m, 6 times m,
Yes.
m is mg upon c squared,
Okay.
dimensionless. That is the last stable orbit for a particle in the
To
Schwarzschild
stay around.
geometry.
Okay.
Schwarzschild geometry is basically geometry we take. In the Kerr geometry, it is little closer than that. And anything crossing the 6m will be sucked in by that.
Okay.
So normally, some matter beyond 6m, they can form a disk. That's called an accretion disk.
That is what we see the light around the black hole.
Yes, normally. Accretion disk geometry, accretion disk physics is very important.
Right.
Now, that accretion disk has matter, which has pressure, density, temperature. So there is hydrodynamics and thermodynamics of that.
Okay.
So one has to really incorporate
Everything.
all this into the relativistic equations.
Right.
And so it is a highly complicated, mostly numerically done. But I did not resort to numerical techniques at that time. Somehow I have been a purist a little bit,
Okay.
in the sense that I would like to see analytical solutions
Right.
which seem to give me a better understanding than numerical.
Of course, it would give you
So-
results more than you're looking for.
Yes.
It would give also.
Yeah, and in analytical solution you can even sort of gauge what could happen.
Yes.
So I was, most of my work is based on the analytical work, but of course to solve the equations you need computers
Yes.
because they are a set of non-linear second-order partial
Differential.
differential equations.
Yes.
You know already second-order partial
It
differential
is
equations.
quite
There is no
complicated.
God-given path to solve them,
Yes.
and then it is also interlocked because
Ah.
gravity is a self-interacting force.
Right.
So because the changes the but you cannot take change in the geometry. You assume the geometry has not changed, but the hydrodynamics of it is changed because of the geometry.
Right. So it is
That's what we take.
something it's hard to imagine on while we are on Earth that what's happening over there. Not changing the geometry, not changing the dimensions, but the changes in.
Yeah, you change it to accommodate that. into
Right.
it.
Right.
So that is what mostly accretion dynamics it's called.
Okay.
And it is because based on general relativity, it becomes relativistic astrophysics. Now, of course, this is very interesting because this is something where you get lot of astrophysical data nowadays. Now, with improvements in space technology after 1950, satellites have gone in, and there are, as you know, Hubble is there, Hubble
Yes.
telescope is there, and now there is Webb, which is the recent one, and that is the very crucial point, the Lagrange point, because it is also the coldest place, and from there it can see in the infrared and far infrared also, and so the amount of data that comes in is enormous.
Yes.
Amount of, so we have to understand that
Right.
and to analyze that. So it gives us an idea about what is happening in the interiors of these objects.
Right.
How do they radiate?
Yes.
And this radiation, as it comes through the space, which is occupied by matter,
Right.
that also can change the properties of this
Of course, yeah.
radiation. For example, electromagnetic radiation,
Yeah.
as you know, is emitted by most of the objects,
Right.
and there is plasma in the space. So when it comes through the plasma,
It changes.
interaction. There is interaction between plasma and the wave.
Okay.
So this wave plasma interaction produces certain changes
Right.
like polarization,
Okay.
and that studying that one tries to understand what the media is about,
Okay.
what medium it is coming through.
Right.
That's what one can understand. So these are very, very interesting.
So the
topics.
approach that you just told about it, getting into the purest approach, not taking this analytical, is it is it similar with what Einstein did back then for GR?
Well,
This
actually,
approach.
Einstein's time there was no computer, this kind of thing.
Right.
He did only analytical.
Okay.
All he did was paper and pencil, analytical, all the things. And of course, the solution was obtained by Schwarzschild. Einstein got the equations.
Right. Okay.
That's also a very interesting thing. I should tell a story.
Yes.
Many people may not know. Einstein, after giving special theory of relativity, which came out in 1905,
Yes.
as you know, in special theory of relativity, you have velocity and relative velocity. Acceleration is not considered there because in special theory we talk only about uniform
Yes.
velocity. Now, if you bring in acceleration, it's a force.
Right.
So it will be a little different.
Complicated too.
So Einstein has been thinking how to bring in acceleration. Particularly, he was interested in bringing gravity because gravity is acceleration. So he thought, he knew that he has to develop further, you have to make something new.
Right.
But then in 1912, he just made some changes into his equivalence principle that was there already in special relativity, in the sense that it was there, but he used it. Equivalence principle says that the inertial mass and the gravitational mass are the same.
Okay.
This was shown experimentally also by Violin in 1895. So it was known. But Einstein used that, and as is always said, Einstein did mostly thought experiments.
Yes.
Unlike other people doing regular experiments. In mind he did the experiment. He thought that is there, and then he said, I have to bring in acceleration into this. So it means you have to change from the velocity. So instead of velocity, you have to get relative acceleration
Okay.
instead of relative velocity. So given these constraints, he had gotten the various
Equations.
equations that is obtained. And now his job was, I can't say his job.
Yeah.
What he did was to produce the beautiful theory of relativity. And that theory came in 1914. But then what happened was, in 1912, he had already thought that he had included acceleration, he had got some set of equations. Now when you get those equations, you have to test it. So he wanted to find out what test it is. And so he thought, what happens to light when it comes near an accelerating body? How does the photon interact?
Right.
So he did this redshift experiment theoretically, and he got that the incoming radiation from there will be a shift in the
Yes, redshift.
redshift will be there, and from his preliminary equations of 1912, he had got a redshift only half of what is
predicted.
observable, what was observed later.
Okay.
And already some experimenting people, they wanted to test that. And this can be tested only through a total solar eclipse, because you have to take a picture of a star. The sun is there, but star is visible only in total solar eclipse. And then after 6 months, you compare the position of the star, and then you get the. That's how they do it.
Right. So it's a really time-taking process.
Yeah. So when people wanted to try, they were to go to Russia for doing, because Russia there was a total solar eclipse.
Okay.
It just happened in 1912.
Right.
This team from Germany could not go to Russia because of the war,
Oh.
First World War.
Right.
And so they didn't go at all. It was a God-sent gift to Einstein,
Okay.
because he had realized somehow that those equations were not complete. He didn't have a complete theory.
The results were just half.
He wanted actually a full theory. And then his friend Marcel Grossmann, who was a mathematician, he suggested to Einstein, why don't you try the curved geometry, Gauss's curved geometry.
Right.
So, and that was the Riemannian geometry. So it is Marcel Grossmann's advice that Einstein used Riemannian geometry. And using Riemannian geometry, he produced the equations, and in those equations, Schwarzschild, who was already in Russia in prison, he got this equation and he solved it.
Okay.
He was the first to solve in 1916.
16.
It's called Schwarzschild geometry. And that geometry, if you use, and now calculate the redshift,
Right.
you get the correct one. What is observed, he got some numbers, which was twice the number he had obtained earlier.
Okay. Huh.
And in 1919, when Eddington took his team to Brazil to test, because there was a total solar eclipse, the number he got was exactly that, what Einstein predicted. So that was the best test of general relativity.
Right.
In fact, Einstein's theory proved to be right because first it had explained the lacunae in Newtonian theory in the perihelion motion of Mercury.
Right.
It was already known result, but
he proved
theory
it.
was not serving this
It
suggestion.
served it.
And he predicted something, this bending, and that also got
Got
proved.
proved.
So in 1920, Einstein became world famous.
Okay.
Yes.
Right.
That's how the theory became the most beautiful theory of general relativity of gravitation.
Right.
And that applied to astrophysics. In fact, you cannot escape applying GR because it's happening up above, far away.
Right.
It's so much of gravitating mass, so curved space-time is there. And of course, he had also predicted gravitational waves.
Back then.
Einstein back then, in 1917, he had predicted gravitational waves because when he took this equation, Einstein's equations are nonlinear equations. But if you linearize it,
Okay.
then he found that the solution was there for that.
Okay.
Because the wave solutions, if they are linear waves,
Yes.
superposition is possible.
Yes.
Nonlinearity does not permit that. So when he took that, and he said there must be gravitational waves, he had predicted.
Right. Total theoretical work.
Yes, and that of course people are looking for it.
Ah.
And in that context, Professor Weber in Maryland, he was the first who tried to make big aluminum cylinders, which he thought that the gravitational wave passes, it produces vibrations in the cylinder,
Okay.
and that using a piezoelectric effect,
Right.
you can convert to
Electrical
signal,
signals.
electric signal, and to measure it.
Right.
In 1970, mid 70s sometime, Weber had started, and 78, 79, he thought he had got the wave. In fact, he even wrote letters to all the people who were working in the field, and but unfortunately later on it was shown that other people who were testing were trying to get gravitational waves, they didn't find it. And if that were to be a real effect, then the amount of energy required from where it was starting was absolutely high,
Immense.
which was not possible.
Yes.
So at that time in 1972, when it was confirmed that there is waves and you cannot just do this way, then people were wondering. Then this LIGO project, LIGO started.
Right.
And also just before that, in 1974, Hulse and Taylor, they discovered this binary pulsar. The two pulsars
Star,
going
yeah.
around each
Yes,
other.
yes, binary stars.
And now two stars are going around each other.
Yes.
Now, if they are losing energy by gravitational wave,
Right.
then that orbit should come closer.
Right.
And that was shown. Because from 1974 to 1986, 87,
Okay.
continuous measurements
Of binary stars.
showed that there was exactly the reduction
Of
in their
radius.
orbit. It was exactly as predicted by general relativity if by emitting gravitational waves.
Okay.
So gravitational waves were proved to be right already
Yes.
at that time, but then it was not detected on Earth.
Okay. So they do
That
exist,
was-
but we haven't detected it yet.
So then that's how they spent a lot of money on that sub LIGO
Right.
and Virgo. They continuously were doing things. But then the problem for them was, so you had to simulation. Simulation is required here. And somehow the already existing computer programs they had, simulations were not really, had not developed to that extent to give precisely what they wanted.
Okay.
But in 2005, a mathematician, a computer man, he wrote a program which was perfectly good for the analysis. And in 2015,
Okay.
they got the first signal of gravitational
Gravitational
wave
Okay.
on Earth. And Virgo and LIGO and Virgo both shown that signal was there by using this interferometer.
Yeah.
And that's Gurudat also has worked on
Gravitational
that,
waves.
gravitational waves. And of course, I have also worked in this area. And so this is something, because so all based on general relativity.
Right.
Everywhere it is GR.
I had this one more question. Do you know, sir, what is common between Albert Einstein, Sherlock Holmes, the fictional character, and you? There exists a nice thing. Would you like to guess it?
You can tell me?
All of you play violin.
Yeah. Well, I can only say I'm a student. I've been trying to learn.
Okay.
And for the last 1 year, I haven't had classes.
Okay.
So I could not really.
No, sir, don't
practice.
worry. I'm not gonna
I mean,
ask you to play it. Another question would be if you were given this authority about changing something about how science is being treated in our country in recent times.
Well, recently, of course, this question has been discussed at length in different fora.
Yes.
I'm sure all the academies have discussed this, and I find that there have been committees and committees which are doing these things.
Yes.
And of course, for example, ICER is a very good idea.
Right.
This is something which we discussed in the mid-90s
Okay.
in Gujarat Science Academy. And because, as I said, we used to run quiz program for the 9th, 10th standard level students. And I used to admire some of the kids who used to come there, and sort of very bright. And then, somehow at that level they used to have so much passion about doing science, physics, mathematics, etc. But somehow after that, they were goaded to go for engineering or something else. by parents or by somebody else, and then they lose track of the whole thing.
Yes.
And there were many students. In fact, my son, when he was in IIT Bombay, he used to tell me that people from the engineering department, some of them bright ones, they want to do science, but really they don't have a clue, because they were forced to join this. There were some of them who just left the place because it didn't really provide the opportunity for them. So we should have, what is my opinion in this is, of course, the skill development is something which they are doing now, which is very important. Like in the German system, that's what I had seen in Germany. There, it's not that everybody has to go to college. Nobody thinks like that.
Okay.
But there is a school level. It's a really excellent teaching going on there. You teach not just teaching, even the kind of handwork that they do. I learn all that, and then they learn some skills.
Right.
Once they learn the skill, by the time they are 18, everybody would have got some skill. They can depend on that.
Right.
They can have a profession immediately.
Right. At the age of 18.
18.
Right.
And then, after a few years in that, then they can come back. See, that is there. They can come back to the system and do their graduation or whatever is required. If we also make our system also relaxed
Right.
and give this opportunity for children who live for various reasons. It could be family reasons, it could be other reasons. They live at a certain age. They should be given an opportunity to come back to this
Right.
without any stigma.
Right.
But that we do not have that provision yet. We need that provision. And I don't know. Of course, as a theorist, it's easy for me to think of an idea, but then a practical problems,
On-ground situations.
people are working in it, they know. But then it is time to really discuss this aspect and see how, any change should happen from the lower level. From the primary level it should happen. So, and then after the matriculation, given opportunity to learn some skills.
Right.
These polytechnics are there. They say that that's where people can learn. But, they should be encouraged after learning for 4 years and getting a diploma and getting a job. They should be able to come back to the system and do a regular course and get a graduation and go for higher studies also. One thing, of course, in this country still the question of job opportunities are not so good yet. And so people, if they leave the job, they think it may not get back the job. And whereas European countries, it is not like that. They are a little better in this.
Well, maybe that's why this engineer and doctor conventionality came from the word job security.
Yeah, mostly it is job security.
Exactly.
And but then people who can afford, there may be families where people may afford it.
Right.
And unfortunately, people talk about illegal methods of gaining degrees and things. That's also is something which is bothering too much, because every day you read something or the other where you find that false certificates being produced, and this is very unfortunate. For that, they should have a system where they really, find out such things and really try to stop that. And for all those who are really good and sincere, give more opportunities.
Right.
And of course, nowadays I find that the government is trying to do its best by giving more scholarships in different areas, in different sectors. And that is a good thing. And that will perhaps help. And maybe another 5-10 years, things might improve a lot.
Yes.
And as I said, hope.
Tip number 3, hope.
Never give up hope.
Right. So as we went through this about education system and your take upon what you would try to change or even have hopes upon. So what about the community of scientists, and let's say in PR, you've had such a long exposure over there. If you would just want to change any mere thing, let's say even if it's significant or a very small thing, what would you, if you're given the authority, do you have any such feelings that you would have changed something, or you would have a different approach upon something?
To be honest, it becomes very personal because since I was there and I had seen it different times and things have changed, but things changing maybe it is necessary for them, for the new system,
Right.
because things have to go according to the system,
Right.
and particularly a government-sponsored institute. It's not a private institute,
Right.
and they may have certain obligations to follow, and therefore it may be an outsider. Now I'm an outsider after all,
Of course.
and therefore I mean I could only say it will be nice if some of the things that were there earlier is it kind of comes back in the sense of interaction with faculty, interaction with others. Of course they do have a lot of lectures in different areas. I find that particularly these years they had colloquia in different subjects. In arts also they had some subjects. And I think that should be encouraged more. And they should have interaction. And people within the campus also more interaction among themselves. Not just scientific, social interaction.
Okay.
That will be very necessary.
Great.
Maybe families getting together.
Okay.
That I find that
It actually helps when you're
Well-
bonded and you work together as a team.
Yeah,
It
yeah.
gives
Yeah,
exponential
because
success.
as youngsters we enjoyed because the senior colleagues and they're with the families, we used to entertain, we used to go visit them all, and everybody used to be, kind of very friendly with each other and all. I mean, now I think the pressure of work, and also I can understand in small families, they have to look after their children,
Right.
and in every system there is so much of, what is it, conditioning, that they may find difficult to go out
Take
and
time
do.
to socialize.
So it may be difficult. So
Okay.
I should be very practical in this.
Right.
I mean, now that I am free,
Yeah.
I might have a lot of ideas that it can be done and all.
Okay.
But I must also put myself in that shoes and think, is it really workable?
Right.
See, ambition is something, but what is workable has to be done.
Practicality.
But make it practical in the sense that, I mean, not fully, but at least partially
Okay.
have some things done.
Right.
That can be, this people have to sit together and discuss and do it.
Right, right.
That will be, I would say. Because, in a committee, if there are particular questions, then one can answer this question. Okay, now somebody else may say, okay, this raises this problem, then look at that problem. So that will be easier,
Right.
than individual, as I think, and then only my personal point of view will come.
Okay.
But I should also include others' personal point of view,
Right.
then see how this works in that way.
Right.
Then it will be, of course, useful.
Then moving on to then what would be your guidance to people who are trying to pursue their career in science, or to the ones who would get some advices early in their life, the early researchers, the young scientists who are
Yeah.
trying to get into this?
Yeah, as I maintain always, find out your niche. Find out what exactly harmonizes you.
Okay.
I mean, there is something when you read or something when you hear, it beats in you. This is very nice.
Right.
So then keep that in mind. Follow that path. Try and do that to the maximum extent. If it's a question of doing mathematics or doing physics or doing chemistry or biology, don't think of whether you'll get a job in this or no. You will, of course, it is there certainly,
Right.
but that should not be the main aim.
Right.
The subject that you are, or the idea that you had in your mind, to develop that should be the main thing. But and also keep in mind, the next track is, of course, you should go to a end should be that you get a job and you get a good life. So finally, that is what it one wants. And luckily nowadays, even in the scientific profession, the job situation is not that bad. If someone is very good, they can get a job, and salaries also are much better
Yeah.
than earlier times. So that constraint is not there. Money constraint is now much less than what it used to be, and therefore concentrating on your goal,
Should be the
the
priority.
subject, and then working with the colleagues.
Right.
These two important things you must
Okay.
have. That is
Any other qualities would you like to include to become good at this field as an early researcher?
No, work.
Okay.
I mean, hard
All
work.
those 3 tips of luck.
Hard work and whenever an opportunity comes, opportunities, take it and
Like
use
right,
it to
you
your best.
wrote that postcard. Be an opportunistic and optimist. That there would be a reply.
Yeah, I mean, if I had felt nervous about writing, it would never have happened.
Right.
Since maybe it's as somebody says, maybe the future was also already predicted.
Yeah.
The timeline was there already, world line was there, and in order to go into that world line, I should have some initial conditions,
Right.
and that initial conditions automatically came and conspired to be together, and so it went, the trajectory went
Right.
unheeded. It's possible,
Right.
and I believe in that
So you
trajectory.
believe in destiny.
Not I don't know whether it's called destiny
Okay.
or fate or whatever it is. There is a certain amount of, they say, past is history, future is mystery, today, present is gift. So enjoy the gift.
Right.
So live in the present,
Right.
always. Of course, people talk about multiple tasking.
Yeah.
Multiple tasking is, a good thing, but not while doing science.
Okay.
While you are doing your science, don't do the multiple tasking. Do it full concentration. Anything that you want to do, only be present for that. While doing something, don't be thinking of something else. This is what many people do the mistake. You'll be doing something, but then they'll be thinking what happened in the past or what will happen in the future. And then the present gets spoiled. So give your concentration on the present. Let future be only a goal and past only an experience. Let them not interfere in the present. That is the best thing that I would say.
So that would be your advice as in general to
Yes,
all
in general.
youngsters.
It's, as I said again, whether you do science or anything else, whatever you do, be in the present and do it with full concentration. And that helps.
So the list was pre-defined about the questions. I have one more question that I would like to ask off the list, if
Yeah.
you're allowed. Were you mischievous as a child? And if yes, I would love to know, would you like to share a memory about any mischiefs that you did, any college days or something?
Well, unlike today, those days there was no opportunity to do anything in a big scale of getting something. But then we cousins used to get together and in summer vacation, and then we used to do some experiments by ourselves.
Okay.
And one of my older cousins, two of my older cousins were in high school, and so they used to know, they used to get some chemicals and salts and things like that.
Okay.
So we used to put together things and work. And one day, without realizing, we put things in, a lot of ammonia came.
Oh.
All of us started coughing and running around. So that kind of thing. But it was not tractable. I mean, it's not like to take a model and dig it out, and that kind of thing was not there. Everything was mostly, and of course, I was also called a bookworm.
Okay.
I used to read
Right.
quite a lot, and one of my hobbies was to go around the second-hand bookstores
Okay.
and look for anything.
Good
And
books.
very old, something called Science News used to come.
Okay.
And when I used to go, it was already second-hand.
Ah.
But I used to pick up those things, and there used to be very interesting articles in that. So I would read them. And reading is something I have
We
been
can
doing all
see
the
that
time.
all over here. Like,
Yeah, that is the
more.
best hobby,
Right.
and I enjoy that. And of course, I used to later I used to read. I do read novels also, in the sense that fiction also I read.
Okay.
I mean, I have no hesitation in admitting I do it.
Okay.
Write
Fiction.
in fiction, and I mean some serious reading. Sometimes I think what should be. I mean, I wrote some posts also. We had a small group called Consciousness. We were all we used to meet in this LD College of Indology,
Yes.
and three colleagues of mine from PRL and somebody from SAC and some outsiders also. And we used to sit together and discuss about various things, and basically consciousness. That is some subject which I do think about quite a bit. And consciousness, like is it relative or absolute? And then time and consciousness. I've written some articles on that. And what is the role of time? And that's very important. And the concept of time is so different in ancient Indian scriptures, and talk about the times associated with creators and gods and all. It's in a different scale. That is something like 1 year of human being is 1 day of Brahma or something. That kind of time.
Right. Relativity.
That is not what they consider, seriously. And that's why this various after person they do this once
Rituals,
a year, rituals, because they think that for the soul it is only 1 day, whereas for you it's 1 year. Like that, this is essentially how the time expands with given constraints, and that's a very interesting concept.
Yes, yesterday only we were looking for a book. We wanted to gift you something about this. So we were going through what would you have not read. We were just so flabbergasted, like you have everything. What can we gift you? We went through those books. One was like from Shiva to Schrodinger, and then another was like the genome of Om, something these books like. And I was like, Professor would have definitely read all these.
No, I don't think I have read that. Anyway, it's fine. That's very kind of you. Think of that.
And I would. What would you like to give this message to our viewers about the role of scientists? And
the role of science and scientists. The role of science is very important for everybody. Right. And the life of a scientist is something should be appreciated by the society. Unfortunately, society has not still gone to the extent of understanding scientists. Right. Because I don't hear many families, when talking to the children, talking about, oh, you become a scientist. I have not heard this. And therefore, it should be. Whereas they say administrative officer, IAS officer,
that is
a big doctor,
really
all this there. So, I want society to get the scientist also the same status.
Right.
And that is very helpful.
Yes.
Because scientist then feels that there is a status in the society. That will give a self-confidence. And because otherwise, there may be a lurking feeling in a scientist. Oh, see, I don't know, I'm just doing it, but others is it okay? Should I do something else? That always can pursue. Unless they are so determined, they don't care about it.
That happens after years of experience. What about the new ones?
No, well, I honestly cannot, say what the young scientists of today are feeling, or even among my colleagues. Unfortunately, we never discussed this aspect of, like I never sat with a colleague of mine to say, okay, what is it that you like to do without science, if you are not doing science? This kind of discussion we never had, unfortunately. I mean, there are very, very, I would say 1 in 10,000, 1 in a lakh who may be interested in
off-the-topic conversations.
Topic of that conversation. It's unfortunately, of course, I did not, honestly, I didn't have any colleagues of mine with whom I could discuss these things.
Right.
And much later, there are some 1 or 2 younger colleagues who showed interest. And we had, one of the things that we did was, of course, this BSc program that we are running. That is something which we had discussed in the 90s when Raghu joined PRL, Raghu Rangarajan. He joined PRL as a postdoc. And at that time, I used to earlier run these quizzes. Science quiz is something which I have conducted many times. And he knew that I had a lot of interest in popularizing. So he said, something we can do. So we thought this BSc program thing. And that succeeded really very well. And you must be knowing, since sometimes in summer they are normally hold
at Xavier's.
Xavier's itself. It used to be started first in Science City we had, and then Community Science Center, and now also Xavier's has taken the full responsibility of running the program. That's a very interesting program, and I find that some of the youngsters who come, they are really very good.
Yes.
They are really interested in the subject.
Right.
That is all that is required.
So,
And deep interest helps.
right. So, any concluding message would you like to give to our viewers, as in based on even science or anything, the message you would like to convey to?
Well, I would, as I said, the main thing is science has to be pursued,
Right.
and pursuing science is a hard task,
Right.
but it should not be given up with any particular deviation.
Right.
And as far as possible, do your science, learn by observing, asking questions, and relating it to your own experience. That is more important. When somebody says this may happen so, you think, does it really happen? All right, let me experience. Or my experience, does it show? And if it's positive, then of course go ahead. Otherwise, you look and see why it is not happening.
Right.
The next question is why it is not
Why is it
happening.
not
Is there something lacuna in my own approach, or is it something that is not feasible?
Right.
So these things you should really work out for yourself.
Yes.
And taking some advice is good, but don't depend on the advices all the time. Any advice, take it, think on it, and if you feel convinced,
Yes.
follow it. That is my sincere